Good morning everybody. Today we shall discuss about the class 9 Is matter around us pure? So in previous class we shall discuss about the pure substances, mixtures, types of mixtures and importance of solutions. Okay dear students, today we shall discuss about the concentration of solution. So here in previous class, we shall discuss about solution. So once again, I repeat it. A solution is a homogeneous mixture of two or more substances. A solution is a homogeneous mixture of two or more substances. So that's why it is called it as an solution. For example, lemonade tastes, etc. So this shows that particles of sugars or salts are evenly distributed in the solution. So today we shall discuss about concentration of solution. So here, you understand that solutions are relative proportion of solute and solvent. So depending upon the amount of solute present in the solution, so it can be called a dilute, concentration or saturated solution. So depending upon the amount of solute present in a solution, it can be called a dilute, concentration or saturated solution. So here the concentration of a solution is the amount of solute present in a given amount of the solvent or solution. The concentration of the solution is the amount of solute present in a given amount of the solvent or solution. So you know that in your previous class solute and solvent means. Here the component of the solution that dissolves in larger, thus it is called it as solvent. The component of the solution that dissolved in solvent, so it is called it as an solute. Here the solvent means, so for example, sugar solution or salt solution. Here in sugar is the solute and water is the solvent. So here the concentration of the solution is the amount of solute present in a given amount of the solvent solution. Here concentration of solution is equal to amount of solute by amount of solvent, or concentration of solution is equal to amount of solute by amount of solution. The concentration of solution can be expressed as mass by mass of percentage by volume percentage. The concentration of solution can be expressed by mass percentage or mass by volume percentage. Here, mass by mass percentage of a solution is equal to mass of solute by mass of solution into 100. Mass by volume of the percentage of element is equal to mass of solute by mass of solution into 100. So here and then properties of suspension. Here suspension is a heterogeneous mixture. Suspension is a heterogeneous mixture because the particles can be seen by the naked eyes. The particles of a suspension can be seen by the naked eyes. So observe these figures. So how suspensions will be and takes place. Here solute particles can be separated by filtration. Solute particles settle down and the solution is unstable, and solute particles are scattered lights and the path of the light is visible. Here suspension is a heterogeneous mixture. So look at the second figure. Here the particles of the suspension can be seen by the naked eyes. Here the particles of the suspension they easily settle at the bottom of the beaker. You have easily observed with your naked eyes. So the particles of a suspension scatter a beam of light passing through it and make it path visible. Here observe the third figure. So here the particles of a suspension scatter a beam of light passing through it and make it path visible. And same as the solute particles settle down when a suspension is left undisturbed. So that is a suspension in unstable in the figure 2. They can be separated from the mixtures by the process of filtration. Observe the figure 1. So they can be separated from the mixtures by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. So here the suspension, it's easily to know that here suspension is a heterogeneous mixture because it can be easily to see with the naked eyes. The solute particles can be separated by filtration. The solute particles settle down and the solution is unstable. The particles of scatter a beam of light passing through it and path of light is visible in the solution. Once again I repeat it. Here a suspension is a heterogeneous mixture of two or more substances. For example, solution of sand in water, solution of chalk powder in water are the examples of suspension. Here the properties of suspension. So here suspension is a heterogeneous mixture, means it is a non-uniform composition. The particles of a suspension can be seen by the naked eyes. The particles of suspension scatter a beam of light passing through it and make it path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixtures by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. So that is the importance of the suspension. Here next one is colloidal solution. Here colloidal solutions means the particles of a colloid are uniformly spread throughout the solution. The particles of a colloid are uniformly spread throughout the solution due to the relatively smaller size of particles as compared to that of suspension. Due to the smaller size of particles as compared to that of the suspension. The mixtures appears to be homogeneous, but actually a colloidal solution is a heterogeneous mixture. Actually a colloidal solution is a heterogeneous mixture. For example, milk. Milk is the example of colloidal solution. Because small size of colloidal particles we cannot see naked eyes. Can you see the small size of colloidal particles with your naked eyes? No, we cannot see small size of colloidal particles with our naked eyes. So, but these particles can easily scatter a beam of light visible. But these of light, it can be easily observed, scatter a beam of light. So here the scattering of a beam of light, so it is called it as Tyndall effect. So after the name of the scientist who discovered this effect, so here the Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. So see this the Tyndall effect. How Tyndall effect will take place. So here Tyndall effect, observe these figures. So when a beam of light is passed through a colloidal solution, the colloidal particles, the scatter of beam of light and the path of the light becomes visible in the solution. So this effect is called Tyndall effect. So see figure number 1. So you easily identify that how Tyndall will be and takes place. So here Tyndall effect can be seen when light enters a room through a small hole. So observe the figure number 2. So you can easily know how Tyndall effect will be takes place in a small room through a small hole. So due to scattering of light by the dust or smoke particles. And then Tyndall effect can be seen in a dense forest due to scattering of light by water droplets in the mist. So see figure number 3. So how Tyndall effect will be and takes place in the dense forest. Here Tyndall effects can be seen in a dense forest due to scattering of light by water droplets in the mist. So simply to say, here Tyndall effects means a beam of light is passed through a colloidal solution, the colloid particles scattering the beam of light and the path of light becomes visible in the solution. So this effect is called Tyndall effects. So you have to easily know through the figure number 1, 2 and 3. And then properties of colloidal solution. So, a colloidal solution is a heterogeneous mixture. A colloidal solution is a heterogeneous mixture. For example, mix of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke are the examples of the colloidal solution. So, that's why colloidal solution is a heterogeneous mixture. The particles cannot be seen by the naked eyes. The particles cannot be seen by the naked eyes. In colloidal solution, the solute particles cannot be separated by filtration. The solute particles cannot be separated by filtration because the particles are too small. So, the colloidal particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable. The solute particles do not settle down as compared to the suspension. In suspension, the particles are settled at the bottom of the beaker. But in colloidal solution, the solute particles do not settle down and the solution is stable. The particles scatter a beam of light passing through it and the path of the light is visible in the solution. The particles scatter a beam of light passing through it and the path of the light is visible in the solution. You have observed in the Tyndall effect. So here they cannot be separated from the mixtures by the process of filtration. But a special technique of separation known as centrifugation. Through the special technique, so it can be an easily to separation. This technique is an centrifugation technique. Here, centrifugation techniques can be used to separate the colloidal particles. Here, the components of the colloidal solutions are the dispersed phase and the dispersion medium. The solute-like components are the dispersed particles in a colloid from the dispersed phase and the component in which the dispersed phase is suspended is known as dispersing medium. Colloids are classified according to the state: solid, liquid, or gas. Colloids are classified according to the state, solid, liquid, or gas of the dispersing medium and the dispersed phase. Okay, dear students, today we shall discuss about the suspension, colloidal solution, and then Tyndall effect. Okay, thank you.